Yo, hi all. My name is Michael Weiss from Hitex in Germany. I am Senior Account Manager, and I will give you a brief overview about what SafeTpack is. Mike, please, the next slide. Okay. Why SafeTpack introduction? And then I will hand over to Mike Beach, who is one of the lead developer of the SafeTpack, and he will give you a deep insight into the SafeTpack and technical overview and what SafeTpack is designed for. And after that, I will give you a brief overview over our services and the license model. And I hope at the end we will have some time for question answers. Okay, what's new in the AURIX second generation? The AURIX second generation has a lot of improvements in terms of performance, scalability, data security, networking, and supply security. And today we will cover the functional safety enhancement of the AURIX second generation. Hitex has a long-term experience in integrating functional safety into AURIX systems with the so-called safety lib in former times. And this experience of Hitex is covered in the SafeTpack framework for the AURIX second generation to give you a fast way to achieve your required safety goals in your system. Next slide, please. Next slide. So Hitex SafeTpack is a complete safety manager for AURIX second generation that provides you a shortcut to implementing the safety manual requirements. And when we talk about safety manual in this context, we talk about your safety manual of your specified application. Like the ProSil safety lib for the AURIX first generation, the TC2XX, it provides a rapid and straightforward way to achieve the safety goals for ISO 26262 or IEC 61508 certification for safety application using the AURIX second generation, the TC3XX. If you have still developed some applications with the AURIX first generation, the TC2XX, the safety lib gives you a fast migration path from TC2XX to the AURIX second generation, the TC3XX. So that's an overview of what the SafeTpack is designed for. And now I hand over to Mike Beach, who will give you a detailed introduction into the SafeTpack and about the technical insights. Mike, it's your.
Okay, thanks very much, Michael. Okay, well, I'd like to say a few words about the details of the SafeTpack. I won't go into too much detail, but please feel free to ask questions if anything is said that doesn't make any sense. I have to assume a little bit of knowledge of the TC3XX on behalf of the audience. The background of the SafeTpack is that we have many customers working with the safety lib on AURIX TC2, so TC275, 234, and so on. The official word from Infineon for TC3XX is that the safety lib is no longer required. Well, this is not strictly true. In fact, it's the microtest library from the safety lib which is not required because there's some hardware built into the AURIX that allows some of the startup tests to be performed automatically. However, the safety lib was not just about running the microtest library. On TC3XX, you still need to do an awful lot of preparatory work before you can run a safety application. So you have to manage and test the TLF 35584 Safety Watchdog chip. This is the combined power regulator and safety monitor. You've got to manage the internal watchdogs. This is the individual CPU watchdogs and the overall safety watchdog. You have to run the new LBIST. This is the logical built-in self-test, the MBIST and the MonBIST. These are provided in the silicon by Infineon. There are some things you have to be aware of when you use these, and the safety pack takes care of these issues. You still need to run redundant checks of critical SFRs if you wish to run an ASIL-D. You also need to run CPU and SPU SBSTs if you wish to use non-lockstep cores for safety applications. You still need to think about the external safety mechanisms. You have some way of running these. Now, these mechanisms were formerly known as the assumptions of use, and there are many of these which are very much application dependent. And you also still need to handle any safety relevant errors through the safety management unit. Now, all of these functions have a massive effect on the overall single point fault metric, latent fault metric, and overall fit rate of the system, so they can't really be ignored. And there's a significant amount of effort required to write software to deal with all of this. So we realized that there's a problem here. So the safety pack is our solution to this. And this is essentially a complete safety manager for all of the AURIX second generation devices. This is TC3XX. And like the safety lib, it's a shortcut to implementing the requirements from the safety manual. So it's just doing a number of things. It's coordinating the execution of startup and cyclic tests to make sure that the AURIX CPU and its internal buses are ready to run your safety application. It's managing the watchdog system and the external TLF device, and it's also managing safety related error handling. Okay. It's also supplying some common external safety measures, and unlike the safety lib, it gives you an easy way of adding your own ESMs in. So if you've defined your own external safety measure, we provide an interface through which you can work with the internal safety manager and signature manager of the safety lib, safety pack. Now, it can be used either with or without AutoZAR. We're targeting AutoZAR 4, and here it constitutes an AutoZAR complex driver. Now, if you're not using AutoZAR or MCAL, it can be used independently, so it can run as a standalone application without any of these additional software packages. Okay. Now, there are 4 main sections in the safety pack. There's a test library and test handler. The test handler is the part that really interfaces to the application, and the test library is the part which interfaces to the built-in tests in the AURIX silicon. There's an internal and external safety watchdog interface and the associated drivers, those associated low-level drivers. There's a signature monitoring and errors reporting system, and there's also a safety management unit driver. Now, this is the one provided by Infineon. We haven't implemented this from scratch. Essentially, it's the Infineon SMU driver. So representing this pictorially, we have an upper layer which contains the APIs to the Watchdog Manager and the Test Manager. And then there's a lower layer which contains the Watchdog interfaces and the lowest level drivers for the internal watchdogs, the external TLF 35584. It also includes interface to the SBST and the LBIST and the MBIST. This is the memory built-in self-test. And also over here, we're showing the Hitex program flow monitor, which is a commonly used external safety measure and that sits over on the left there and interfaces into the Watchdog system. And at the lowest level, we have drivers and predefined routines running actually in the AURIX silicon. And the lowest level, there's a QSPI interface down to the TLF 35584, which has the critical safe state control pins, which ultimately will be used to bring a system into a safe state in the event of some kind of critical error. Okay, so going through these components in a bit more detail. The test library includes a handler which is very much like the SafetyLib one, which is coordinating the tests provided by Infineon. The LBIST is probably the most important one, and this is the one that replaces the SafetyLib latent fault metric tests. And within this, the SafeTpack allows you to specify the activation method for the LBIST. This is either at startup or as part of the boot mode header system, so that the processor will have completed the LBIST before actual execution begins. There's also an optional SBST interface for the signal processing units if you wish to run those at ASIL-C, and also SBST for the non-lockstep AURIX cores that you wish to run at ASIL-B. The SBST is a piece of software which is provided by Infineon and which is separate to the SafeTpack. So the SafeTpack provides the interfaces to the software, but the software has to be obtained separately. There's also support for redundant SFR checking. So those familiar with the SafetyLib will remember the SFR, CRC, and SFR comparison tests. These are required for ASIL-D. Now the test manager handles the errors coming back from these tests, and the errors are reported in two ways. There's an application callback, which will allow the application to be informed directly that there's been some kind of safety problem, and the application then can take some necessary steps. But at the same time, there's a test signature of 32 bits in length, which is associated with each test, which is passed back ultimately to a signature monitor. And the signature monitor is the thing that determines whether there is a sufficient problem to cause the external watchdog to time out and reset the system, or at least put the system into a safe state. Now, all of these tests are activated and set up using the Traceos Studio environment, which may be familiar to those of you using SafetyLib and MCAL. Here's just a couple of example screenshots. So on the top left, here is the Traceos configuration for the TLF 35584 driver. And down on the right-hand side, this is the Traceos configuration menu for the LBIST. Okay. Now another part is the Safety Watchdog interface and signature monitor. Now the Safety Watchdog interface is flexible in that it can work with the internal watchdogs on the processor, but also external watchdogs. Now for the lower ASILs, the external TLF 355 watchdog is usually used with the internal functional watchdog. But for the highest ASIL, for ASIL-D, the TLF 35584 provides both the functional and the window watchdog function. Now, we're showing here a table of typical watchdog configurations that the SafeTpack will support. I must stress that this is very much application specific, but what we have here is something fairly typical. So for a typical ASIL-B system, you would probably use the internal CPU watchdog as a functional watchdog and the external TLF 35584 as an independent time-based window watchdog. You can trace this back to an ISO 26262 section 5 or chapter 5 reference through the D 2.9.3. At the highest level, to meet the requirements of the ISO 26262 section 5 D 2.9.5, you really need to use the external TLF device as both the functional and the window watchdog. But I must stress this is very much application specific. The lowest level driver to the TLF 35584 is a specially written high-speed optimized DMA-based QSPI driver. So we're not relying on a QSPI driver from another source. This is one specifically written for the job. Now, the test signature management is critical. Each of the tests that we're running reports a signature value of 32 bits in length. These signatures are collected from around the system, so around each core and within each core, and used to ultimately decide whether to refresh the TLF device or not. The Watchdog interface can be extended to collect signatures from external safety measure modules, as I've mentioned. So typical ones are things like the program flow monitor, the ADC self-test, which includes things like broken wire detection. It collects signatures from the SFR checks, the DMA monitor, although that's a slightly special case, which I'll explain later, and the SBST, and some others like, for example, the dye temperature sensor. Okay, the safety watchdog and safety monitor are intended to be used throughout the running of the process. So this is from the startup phase through the running phase when the user's application is actually executing. So the big advantage here is that you don't have to create your own TLF 35584 servicing system, and you don't have to provide a framework for the cyclic execution of the redundant SFR tests. All of this basically is taken care of by the SafeTpack. Now, the safety watchdog interface and the signature monitor are represented by this rather complex diagram, so I apologize if you find this hard to understand, but essentially it's showing that the signatures are circulating from the individual tests up through the test manager and then into the watchdog interface and ultimately down into the TLF 35584, which is the thing that is actually going to determine whether the system's in a safe state or not. In reality, the TLF actually provides a seed value, which is combined with the signatures coming back from the individual tests. And if the overall value does not match a table within the TLF 35584, then it decides that the system's in an unsafe state. Okay. Now, the TLF 35584 is critical here, and it has its own safety manual. So that safety manual specifies that certain things must be tested within the TLF 35584 before we can actually make use of it in a safety application. So we have to implement the window watchdog test, functional watchdog test, the error pin monitor test, and the analog built-in self-tests. And this is all as per the safety manual. This is a fairly significant piece of software, and it's not something that you can just implement in a few hours. It's a fairly major piece of software development. The future TLF 3068X series of devices will also be supported in much the same way as we do with the current TLF 35584. So the safety management unit is configurator and driver is the final part, and this allows you to configure the SMU for the SafeTpack startup phase, so it's able to then handle all the alarms coming back from the individual tests, for example, the LBIST. But once the SafeTpack startup phase is ended, you can then have a configuration which is the one that your application will use during the actual run phase. Now, the The safety pack itself is a component of a much larger user-defined system. Obviously, as a product, as a piece of software, it doesn't stand alone. It's really part of your overall system. So we supply it in a number of different forms, which will allow you to integrate it into your development process. So for ASIL-B, it's supplied as a source code with a reference application that demonstrates basically how it's used. This is much the same as the safety lib, for those of you that are familiar with this. It comes with an ISO 26262 style safety manual and a safety case report, which should be sufficient evidence for any external certifying authority, such as TÜV, Exida, and so on MIRA. But if these external bodies require more evidence as to the software development process, we can provide assistance with this by special consultancy. You can use a safety packet up to ASIL-D, but there are some special measures you have to take, much like you would with the MCAL, for example. And in the long term, we are intending to support the industrial standard IEC 61508 and the aerospace DO178C and DO254. Okay. So to allow people to get started with the safety pack as quickly as possible, we're providing a fully functional object library version of the safety pack, which has some source code. Obviously, we can't reveal all of the source code to the safety pack in the evaluation version. We provide sufficient for you to configure it and get started with it. This comes with, again, with a basic reference application that shows how it works, or how it should be applied. It's locked so that only will work on Infineon and in Hitex evaluation boards. So this is things like the tri boards and so on, the application kits. The key thing is that it will guarantee that the servicing of the internal watchdogs and the external TLF 35584 are correct from day one, so that you can get on with developing the application without having to worry too much about how these watchdogs are being serviced. And if they're not serviced in the right way, it can cause the board to constantly reset, and it becomes extremely frustrating. So it's highly recommended to use this. Now, this trial version is available free of charge. Now, once you have custom hardware, once your own PCBs arrive, then you'll need to use the standard safety pack ASIL-B development and production version. And this is fully functional source code with all of the TRACEOS configuration facilities enabled. It comes with a reference application again, and the ISO 26262 safety manual and safety case report, and some additional documentation as well. So there are optional modules which you may or may not need. If you're intending to use a non-lockstep core within an AURIX 2G for ASIL-B, then you'll need to run the Infineon SBST as a cyclic function or startup, and maybe cyclic as well. The safety pack will allow you to interface to this module, which comes from Infineon, and the errors from it will be reported back through the standard signature management system. And for the single processing units, if you want to use one of these in a non-lockstep mode at ASIL-C, then again, you will need to obtain the SPU SBST from Infineon, and the safety pack will then manage the SPST slices and report any output status back through the signature management system. So additional optional modules. In fact, the program flow monitor is being shown here as optional, and actually it's included in the safety pack. This is an important module which is required to satisfy the D2.9.5 part of ISO 262 chapter 5. And it's able to verify that critical tasks and functions are called in the expected order, and this can be across one core, across multiple cores. And again, any errors are reported back through the signature manager and ultimately through to the external Watchdog device. The TLF 35584 ABIS is also available, and this is testing the comparator and evaluation logic for the monitoring functions that overall contribute to the activation of the secondary safety shutdown path and interrupt generation. Also, the window watchdog test and the functional watchdog test and the external error pin monitor test is included. There's also an optional DMA monitor. Another one which almost everybody seems to need is the EVADC ESM pack. This implements the broken wire detection tests, out of bounds tests, the internal multiplexer diagnostics tests, converter diagnostics tests, and the voltage reference monitor tests. Again, another one that turns up a lot is the die temperature monitor. So here the monitor is checking the two sensors and making sure there's not a greater than, I think it's 9-degree difference in temperature between the two. The external safety measure modules are written in accordance with the safety manual recommendations, but as is the case with all of these things in the safety manual, you must review that those recommendations are appropriate to your application. We can help with this, so if you need some additional advice, then we can provide consulting services to alter the ASM modules to suit your applications. And as time goes by, we're going to produce more ESMs which will then be available as off-the-shelf items. Okay, now to get started with the safety pack, we really do recommend that you integrate this with the application at the very earliest possible stage, and to this end, using the trial version on a tri-board or an application kit is strongly recommended. It gives you a stable platform which developed with safety application, but also it gives you the maximum running hours with the safety pack before you finally release the product. And the simple point is it's much easier to integrate this when your application is very small than trying to add it to a mature system. Although it can be done, it's obviously a lot more work, and some integration consultancy may be required. This is the recommended way of doing it. Get started with the trial version, and then when your own custom hardware arrives, you need to purchase the proper A2G safety pack ASIL B version, and this will take you through to a full configuration and ultimately to a final product release. At the moment, we are supporting the most widely used tool chains in Europe, which is the tasking version 6.2, the Hitex GCC 4.92, but we are preparing to support the Green Hills system, and that will be somewhat later though. So we're leading with the tasking in Hitex. As regards the silicon support, the first device will be effectively the umbrella device, which is the TC399B step, and then the TC389, and those will be available as alphas basically in the next 6 weeks or so. There'll be a beta version which is basically fully functional in Q3, and then the production release will be Q4 2019. So based on experience that of the AURIX 2G so far, those kind of timescales should match most customer product developments. And then following up, we'll have the TC397 in the smaller package, and the TC36 as an alpha in Q2, beta Q4, and the production release to be decided, but will probably early 2020. Other devices will follow, obviously, in accordance with the Infineon roadmap. If anybody has a particularly pressing need for a device which is not listed here, then by all means contact us and we'll see if it's possible to accelerate the development of a suitable version. Okay, and around the SafeTpack, we have a number of services. To help you plan your system at a safety level around the AURIX 2G, then we can provide functional safety consulting. This can be whatever level you wish, really, whether it's identifying the safety goals or configuring the FMEDA or whatever it is that's necessary. We can also help you decide how to achieve the target ASIL or SIL if it's 61508 with the AURIX and the SafeTpack. This is more general advice. Then specific training, we can provide classroom training on the AURIX architecture. So this is a formal training, sitting in a training room with development boards and pots and LEDs and so on, and actually writing real AURIX applications. We can provide training in how to use the SafeTpack and how to integrate it into your application. And then we can provide general functional safety training. Probably the most important thing, based on our experience with the Safety Lib, is that we can provide integration services for the SafeTpack. So if you have a relatively mature AURIX 2G application and you need to integrate the SafeTpack, then we can help you. If you're bringing an application off the TC2XX, the first generation, which was based on Safety Lib, then we can provide integration services to help you replace the Safety Lib with the SafeTpack. And this is something which we've already had some interest in. We have a network of partners around the world who can also provide these services either through them or directly. And with any of this topic, we're always happy to have individual inquiries, so people just need to contact us and discuss what their requirements are, and we will always try and accommodate them. So that's the end of the technical overview of the SafeTpack. I've had to go relatively quickly because it's a huge topic, and there's only so much that we can fit into the scope of a webinar. So at this point, I'll hand over to Michael, who can say a few words about the licensing and availability of the SafeTpack.
Okay, thank you, Mike, for this technical introduction to the SafeTpack. Here's a brief overview over the product sheet over the SafeTpack for the AURIX second generation family. And on the next slide, we will see which licensing model we have. So at the first time, as Mike has told to you, we have a SafeTpack evaluation license. It's free of charge for 6 months, and it runs only on the Infineon dry boards, and it's for evaluation only, and there is no support and maintenance in this evaluation license. So ask us for getting a evaluation license. We will provide it to you till it's available. So for developing your application, we have a limited development license, and the invest here is 25,000 euro. It's limited for 18 months, and it's only for development. And like the license model for Infineon MCAL, it's for one project and one OEM. And if you upgrade to a reproduction license, then this price of 25,000 euro will be credited. Support is you will get for 10,000 euro per year, and it's limited to 50 hours per license and year. And the first level support is via phone, fax, and email. And if there is any deeper support request, we will arrange second level support by our internal experts. Next slide, please. So we have two models for reproduction license. The first is an unlimited time, unlimited pieces, but only for one project and one OEM. It's an invest of 50,000 euro, and it can be used in unlimited pieces of production. And after the seventh production license, we can offer you a buyout. So the next licenses are for free. And here support per year per license is 10,000 euro per year. Next slide, please. So if you have smaller pieces in production, we offer a so-called royalty license, which can be accumulated. So it starts for 5,000 units at 60,000 euro, and in the 60,000 euro, it's included the development license and a production license as well. And the license is limited for one specified controller, but for unlimited projects, and support per year is 10,000 euro. Next slide, please. Okay, if you have further questions, you can contact us. My name is Michael Weiß. I'm here at Hitex in Germany, or you address direct Mike Beach from Hitex UK. His email address is in the beginning of the slides.